This is just a continuation of the last video, and you'll notice here, I didn't say it in the last video, but you notice we had real coefficients for this polynomial, and indeed that the factors came out as conjugate pairs here. You've got negative 3 on 2 plus root 11 over 2, and this one's got minus root 11 on 2. So we ended up with conjugates here, which is what the conjugate theorem says. We got our two conjugate pairs there, and our odd one out, our real factor there. Okay, let's do another example. Again, this is just one of the hardest parts of specialist maths. Let's look at another one. We've got z cubed minus, I've got to write this correctly, otherwise I'll mess it up, z squared plus z minus 2 plus I. Okay, let's have a look at this. Now, we do not have real coefficients. Look at that guy there. That is not a real coefficient. Okay, we have not got real coefficients. We've also got that there, which is not real. So the conjugate theorem does not apply here. Okay, conjugate theorem, no. That will not necessarily happen. So let's have a look at it. When you've got this type of cubic, in general, the answer to how to factorize this is to look for groupings. And you can already kind of see it. It's written in a way that you can't, but it looks like you've got this 2 minus I here in brackets, and you've got, this is actually 2 minus I, but it's not written in brackets. So you can actually see there's going to be a common factor between these two, and there's actually a common factor between those two. You can sort of see it already, so you need to get good at grouping. It's a really important skill in specialist math. So what I'm going to do is group this. So I'm going to take, I'll just rewrite it so you can see, z cubed plus z. I'm going to group those together, and then I'm going to take negative 2 minus I z squared, and I'm just going to write this in the same way that they've written it, minus 2 minus I. And now can you see here our groupings there? Okay, so let's take common factors out. Okay, common factor of z there, z squared plus 1, and the common factor here is minus 2 minus I. Let's take that out. What have we got left over? Well, we've got a z squared, and we've got one lot of minus z minus I, so that's plus 1 there. And there we go, we get what we want, which is that common factor there. Let's put those two together, equals, now we've got a common factor of z squared plus 1. What is left over? We've got a z here, and also minus 2 minus I there. And it's almost there, I might just neaten it up a bit, equals z squared plus 1, z minus 2 plus I. And also this z squared plus 1 is not fully factorized. Remember, we want 3 linear factors because we've got a cubic, so we can easily do that. You can either do this just straight, I'm just going to do it straight if you don't mind. So we've got, using our what's the square root of z squared is z, what's the square root of negative 1 will be I. So I've got I there, plus 1 and a minus 1. So get used to that particular step. And there we go. There is our fully factorized cubic with imaginary coefficients in it. Okay, I'll go on to our last example, which is probably the messiest of them all. Okay, I'll try to write a bit smaller for this one. So if z minus I is a factor of 2z cubed, oh, I ran out of space here, in fact not, 1 minus 2I, should have started on a new line, z squared minus, don't want to get this wrong again. If you get one little number wrong, it really screws everything up, and you do heaps of work for no reward. 5 I z. Good. If z minus I is a factor of that, then fully I'll just say fully factorise it. Okay, a bit messy in the language, but there you go. We want to just factorise this, and we're told that z minus I is a factor of that. Now, the only thing to do here is to, hang on a sec, I'll just say, can we use the conjugate theorem here? In other words, can we say, well, z minus I is a factor, so can we say z plus I is a factor? Well, no, we can't. There's imaginary coefficients here, and so we cannot assume that there's a conjugate there. So what we just need to do is do it the hard way, and we need to actually do a long division on this sucker. So let's go. Here we go. Z minus I, long division 2z cubed plus 1 minus 2I z squared. You're probably sitting there groaning right this very second, just like I am, because I have to sit here and do this, so you have to sit there and watch it. Here we go. Long division on this. This might look horrible. Okay, so we've got a z there. How do we create 2z cubed? We need to multiply it by 2z squared. So here's our z squareds up here, so 2z squared. Let's multiply that by that. We get 2z cubed minus 2I z squared. Just let me check out, don't want to make a mistake. 2I z squared. Yep, that's right. Let's do our subtraction. That minus that will cancel out. Here we'll get 1. Is it 1? There's only 1 there, so 1, and you'll get a negative 2I minus negative 2I, so the other z squares will just cancel out. So that all you get is 1z squared there. Okay, you can check that, 1z squared. Fantastic. From there, then we bring the next term down, which is negative 5 plus I z. And what do we need to do? Multiply this by to get this term here. We might need to get a z. So we'll add z. Z times that is z squared minus I z. And do your subtraction. That cancels out. What have we got here? We've got negative 5z. So I'll just do the real part first. And so you'll get negative 5z. So negative 5. I'll do the z's in a second. And then you'll get negative iz minus negative iz. So that will cancel out. So you just get negative 5z like that. Fantastic. Almost there. You bring down the plus 5i. And then what do we need to multiply this by to get this? So just mark that. What do we get? We need to multiply it by negative 5. So negative 5 times that is negative 5z plus 5i. And hallelujah, you get the same thing here. So you get 0. So yes, it is a factor. Fantastic. So we've got this as this here as our new factor. So now it's this factor multiplied by this factor. So all we need to do now is, when I say all we need to do, is factorize that. And I might just see if I can just squeeze it in here. I really should get better at not taking up so much space. So let me just do this 2, and I'll just take out the 2. Z squared plus half z minus 5 on 2 equals 2 z squared plus half z. Half divided by 2 is a quarter. A quarter squared is plus a 16th. Yuck, yuck, yuck. What am I doing? Why did I choose this example? Good, equals 2. What does that simplify down? Z plus z over 4 squared. That's that stuff there. And what's left there? Well, that's negative 1/16, and that times 8 is negative 40. Negative 1, so that's negative 41/16, like that. And that's your double bracket there, like so. And so then we need to do our. We'll leave that 2 out the front. No, we have to take that in actually. So it would be 2, and we've got z plus, oh, don't make a mistake, that should be a quarter. My apologies there, that's just 1/4. Sorry, no one told me what I was doing there. Z plus 1/4, and then we've got plus root 41 on is that 16? Can't read my own writing. Over 4I, and the other one, I'm just going to write it here. And then the other one will be Z plus 1/4 minus root 41 over 4I. Now, if I made a mistake somewhere, Z, you're taking everything out. If I have made a mistake, please tell me in class, but that looks correct to me, taking the 2 out. You could put the 2, I made sure I haven't taken that, that's all correct, that minus that. You could take the 2 out into there, but that would not help. No, that's alright, so that's all correct, and so fully factorised, please forgive me for not writing it out, but fully factorised it would be Z minus I times by all of that. Okay, so that would be the full factorisation of that. I'll go through that type of question in class because it's a bit messy here, and yeah, anyway, I'll leave it at that.